Let's talk about the internet. Not just using it, but actually understanding how it works. We're going to demystify the whole thing, the hardware, the rules, all the services that connect us. By the end of this, you're going to see the internet in a whole new light. So let's jump in.
So, have you ever really stopped to wonder how it all works? You click a link, and boom, a whole world of information just appears. It feels like magic, but it's not. It's just really, really clever engineering. And to get it, we're going to build our own little network, right here, from scratch.
Okay, first things first, we've got to start with the basic hardware. These are the physical pieces of the puzzle, the foundation for any network, whether it's the one in your house or a massive data center.
At its absolute simplest, a network is just a cable connecting two computers. They can talk back and forth, no problem. But what happens the second you want to add a third computer, or a fourth, or a 50th? Suddenly, you need something in the middle to manage the conversation.
And that brings us to our first pieces of gear, the hub and the switch. Now think of a hub like a megaphone. When one computer sends a message, the hub just shouts it out to every other computer connected to it. Super inefficient. A switch, though, is way smarter. It's more like a postal worker. It looks at the specific address on the data and delivers it only to the computer it's meant for. This also makes a hub a big security risk. If everyone gets the message, anyone can listen in. Switches keep those conversations private.
And you can see that hub problem perfectly right here. In that little cluster of PCs on the left, if one computer wants to talk to just one other computer, well, too bad. The hub blasts that message out to everybody. It's noisy, it creates a ton of traffic, and it just slows everything down. It's like trying to have a private conversation in a really, really crowded room where everyone is shouting. All right, so we've built a couple of small local networks. One's using a hub, the other's using a switch. And inside their own little worlds, they work just fine. But what if a computer in our hub network needs to talk to one in our switch network? Well, right now they can't. They're like two separate islands. Let's build a bridge. So here's the problem we've set up for ourselves. We have two isolated bubbles. Data can move around freely inside each bubble, but there's no way for it to get from one to the other. To connect them, and to eventually connect our whole setup to the wider internet, we're going to need a new piece of hardware.
And that's where the router comes in. Its entire job is to be the traffic cop for your data. It sits at the intersection between different networks, looks at where a piece of data is trying to go, and points it down the right road. It's the gatekeeper that connects all these different digital neighborhoods together.
Okay, so how does the router know which road to send the data on? Well, there are basically two main ways. There's static routing, which is kind of like giving the router a printed out paper map. The routes are fixed, it's simple, but if there's a roadblock, it gets totally lost. Then there's dynamic routing. This is way more like a live GPS app. The routers all talk to each other, sharing updates on traffic and outages, always finding the best possible path in real time. It's more complex, for sure, but it's also way more powerful.
And here's a perfect look at that static routing idea. The path from the PC on the left to the one on the right is manually programmed into those routers. See that highlighted red line? That's it. The data will always take that exact path. It's predictable, which can be great for small networks that don't change very often.
Awesome. Our physical infrastructure is all built out. The roads are paved, the traffic cops are in place, but a city isn't really alive until people and businesses start using those roads. So now it's time to switch on the essential network services that make everything actually, useful. First up, we've got DHCP. Now, can you imagine if every single time you connected to a Wi-Fi network, you had to manually type in a long, unique number to get on? It would be a total nightmare. Well, DHCP is the service that saves us from that. It's like a hotel front desk that automatically hands out a unique IP address, like a room key, to every new device that joins the network. Next up is DNS, the Domain Name System, and this one is absolutely crucial for us humans. See, computers talk to each other using numbers, those IP addresses, but we're not so great with long strings of numbers. We remember names, like google.com. DNS is basically the internet's giant address book. It translates the name you type into your browser into the number the computer actually needs to make the connection. And finally, there's HTTP. This is the actual language that your web browser speaks to talk to a web server. It's the set of rules for saying, hey, please send me this web page, and for the server to send it all back. You know that HTTP you see at the beginning of a web address? That's it. That's the protocol that makes the whole web work.
So we've done it. We've built a fully functional network in our little virtual lab. We've got the hardware connecting everything and the services making it all work. Now, let's zoom out and see how these simple little pieces come together to create, well, the entire internet.
Take a look at this. On the left, you've got the clean, simple network we just designed. And on the right, yeah, that looks a bit more like the real world, doesn't it? But here's the incredible part. It's all built from the exact same stuff. The super complex network is just our simple network scaled up 1,000 times over, using the same switches, the same routers, and the same core ideas.
And that's really the key takeaway here. Every single thing you do online, every email you send, every website you visit, every video you stream, it's all traveling through a system built on these exact principles. That email is being guided by routers. That website is being found by DNS. It's all happening on a global system built from these fundamental pieces.
So what we've just done is build a little microcosm of the entire internet. We've seen the logic, we've seen how the data flows, we've seen how the services bring it all to life. This fundamental logic is the foundation for everything we have today and for whatever comes next. It really makes you wonder, doesn't it? Now that you know the rules of the game, what do you think the next generation is going to build with it?